Greetings, everyone, and welcome back to our Skies at Night program. This is Seth Mayo again, curator of astronomy for the Loman Planetarium at MOAS, and in this edition, we're covering the dates of August 29th through September 4th, 2022. We're going to start things off by talking about the upcoming launch of NASA's newest moon rocket called SLS, part of the Artemis program to go back to the moon. Then we're going to mention another amazing NASA achievement, this time with the James Webb Space Telescope and the discovery of carbon dioxide in an exoplanet atmosphere. And we're going to end with a look at the upcoming celestial highlights for the month of September. So let's get to it. On Monday, August 29th, if you're looking in the early evening just after sunset in the west, low in the horizon, you may notice the beautiful crescent moon. And by that evening, if this launch does happen, there may be a new rocket eventually making its way to our moon once again. And this is NASA's newest moon rocket called SLS, or the Space Launch System. We've talked about it before in previous programs, and you may have heard about this new rocket because it's part of NASA's Artemis program. This is the new program to get people back to the moon again. So of course we haven't been to the moon since the Apollo program, and there's been development over many years to get people back there again. And so this new rocket that's been in development for quite some time is finally complete and has gone through all this testing and even been rolled out to the launch pad a couple times. We were there for one of those rollouts, which was amazing, earlier this year to see this mega rocket. This is the largest rocket we have seen launch from the Kennedy Space Center since the mid-1970s, since the Saturn V launched last time. And this rocket has to be big and powerful because it has to carry a crew of astronauts to the moon. So it requires a very large launch vehicle. And this one is certainly big because it has about 8.8 million pounds of thrust at liftoff compared to the Saturn V, which had about 7.7 million pounds of thrust. So that's about a million more pounds of thrust than the Saturn V, which was, of course, a mega rocket as well. So this first test launch, it's an uncrewed flight. It's supposed to happen this Monday in the morning. And by the time you watch this, it may have already launched. If it goes, of course, launches, there's a lot of factors to consider. So if it doesn't launch now, then the next opportunity is this coming Friday, September 2nd. And there's other opportunities in September as well. So this uncrewed flight will eventually take what's called the Orion capsule at the top of the rocket, this new capsule design that can carry 4 astronauts on board. So there'll be no one inside, but NASA is testing to make sure everything is working correctly in about a 42-day mission. So it'll take 42 days to test everything, get to the moon, make its way around it, and then head back to Earth. And then that capsule by itself, the Orion capsule, will then plunge back through Earth's atmosphere, hopefully parachuting back into Earth's ocean safely to complete the trip and to make sure everything is running smoothly. And this will eventually lead to a crewed mission. It's supposed to be planned in 2024 to take astronauts just around the moon and then back to Earth again, and then a year or two later to actually land people back on the moon. And NASA's slogan for Artemis is to land the first woman, next man. So there is intent to bring a more diverse group of astronauts to the moon, which is great. So we'll see if this launch goes well. Again, this is the most powerful launch vehicle we've seen from Kennedy Space Center for many decades, about 50 years, close to that much time. And myself and our planetarium crew will actually be down covering the launch at the KSC press site, so it'll be pretty close, about 3 miles away, tracking it with telescopes, taking images of it in video. So hopefully we get a chance to capture that on Monday or sometime when this eventually launches. So we'll see how this goes. This kind of helps us understand the future of this program. And of course, we're going to cover it in various ways and post videos about it coming soon. So stay tuned for that, and go SLS. Just recently, you may have heard the news coming out of the James Webb Space Telescope, that wonderful space-based observatory we've talked about a lot lately, this infrared telescope about 1 million miles away from Earth that is seeing the deepest parts of our universe than ever before. And one of the amazing functions of this observatory is its ability to study the atmospheres of exoplanets, planets found outside of our solar system. Exoplanet is just short for extrasolar planet, and we found over 5,000 of those so far in our sky since the mid-1990s, and that number is increasing very quickly. So recently this discovery was made about a planet called WASP 39b. WASP is the name of a whole bunch of observatories around the world that are studying stars that dim for a moment. When a planet goes in front of the star, it's called a transit, and you can tell that there must be a planet there if the star dims by just a slight amount. So there's a whole group of WASP planets and WASP stars that have been studied and confirmed over the years, and this is one of them. WASP 39 is the name of the star itself that this planet is going around. That's about 700 light years away from Earth. And what's interesting, this is a star that's similar to our sun. It's a main sequence star, a yellow star. And around it, hugging very close to this, is WASP 39b. This is a planet that is super close to its host star, about 1/8 of the distance that Mercury is to our sun, and it only takes that planet 4 days to go around that star in an orbit. So since it's so close to the star, it's very hot, up to 1600 degrees Fahrenheit, and it's a gas planet similar to Jupiter or Saturn. So we call it a hot Jupiter, but it's only about 1/4 of the mass of Jupiter in our solar system, but actually 1.3 times the size of it. So this is actually a very puffy planet. It has a very puffy atmosphere, which makes it a good candidate to study from observatories here on Earth like James Webb. And so when that planet goes in front of the star, some of the light from the star goes through the atmosphere, and we can detect how that atmosphere interacts with the starlight. It can absorb certain colors and certain wavelengths of light. And when you look at that absorption in a spectrum, you can determine the chemical and elemental makeup of that atmosphere. That's called spectroscopy, and it's a very important part of astronomy and understanding the universe. So the James Webb Space Telescope has a unique advantage that it sees an infrared light, which is a longer wavelength of light than visible light, and can see things much farther away in the universe and detect things we had never really seen before. And the results from a paper that was released recently showed us that WASP 39b has carbon dioxide in its atmosphere. We had never really seen that before with any other exoplanet so far, at least atmospheres of exoplanets, which is very, very exciting to see this. This was an observation actually made last July with the Webb telescope. So this data and graphic here provided by NASA really helps you understand what's going on and what was detected here. So this was actually taken by an instrument on Webb called NIRSpec, which is the Near Infrared Spectrometer. And this top sort of graph you could find here shows us how the starlight is pretty steady, but then when a planet goes in front of it, the starlight dips, and that's the dip you see here. This is called a light curve. And then when the planet moves away from that star or out of its view, then the starlight rises back up again to the level it was previously. This dip is actually very, very tiny, but this is kind of zoomed into the dip so you can see it. Now looking at the dip, you can actually look at different colors, red, blue, and green, and notice how some of the light is either blocked or comes right through. So some of the red light you see here is blocked less by the atmosphere. That's what you see here. But down here, some of these colors here are being blocked a little bit more. And if you know specifically how that's being blocked, in this case, it's carbon dioxide. So that's really important to see that absorption or blocking of light in this spectra. And this graphic really does a great job of exhibiting that. And what's so exciting about this finding is that, of course, we know here on Earth, life can produce carbon dioxide, right? You breathe out some of it when you exhale, and then plants take that in and produce oxygen again. So we have this carbon cycle here on Earth, and that's an organic molecule. Now, it doesn't mean that that planet has life. That's a hot Jupiter, probably not a great place for life. But what it can tell us is that we can detect signatures of molecules like that. And this helps us understand that we could potentially detect stuff like this in smaller rocky planets that do have a higher chance for life, maybe detecting methane and water vapor and other either ingredients of life or even the byproducts of life, which is a very exciting part of what the James Webb Space Telescope can do. So this is just showing us the capabilities of James Webb, but also seeing this carbon dioxide can help us understand the evolution of planets, how they form, how they exist today, and we can compare them to other exoplanets over time. So this is very exciting in the early exoplanet research made by JWST, and we'll see where this takes us as time goes on. As we look toward the specific celestial events for the month of September, we're going to start with Saturday, September 10th, which is officially a full moon. And the full moon in September is typically called the corn moon because corn is harvested, and sometimes called the harvest moon. The harvest moon, as we've said before in the past, is the closest full moon to the equinox, which occurs later this month. And what's nice about this full moon, if you notice it rising out of the east that evening, and you can see it all night long, is that the moon will be near the planet Jupiter right there. So you have a nice pairing of solar system objects, Jupiter, which is very bright, and the full corn moon, the full harvest moon rising along with it on that night. What's interesting though, just about 6 days later, in the same area of the sky that the moon was in, because this is still Jupiter, we have Neptune right here, and Neptune will be at something called opposition on this date. That is when Neptune is opposite of the sun in our sky, and that's when it's closest to Earth, technically, in our solar system, which means that Neptune will be bigger and brighter. Now, Neptune is not a planet you can see with your naked eyes by far. It is well beyond the visibility of naked eye viewing, so you definitely need a telescope to see it. But if you do have a telescope, it'll give you a better chance to see this far off world that is the 8th planet in our solar system. We could actually zoom into Neptune here. Most likely in a telescope, you'll see a little bluish dot. Maybe if you have a good sized telescope, to see something much larger is definitely not possible, but we'll zoom into it just for fun here. And even though we are closest to it on this date, Neptune is still 2.6 billion miles away. That's close to 4 light hours away. The light takes 4 hours, even at its closest distance to us, to reach Earth. So it is quite a distance away from us, but on this evening will be the chance to see it, maybe best through a telescope, the tiny little maybe blue dot that you may notice as a beautiful ice giant Neptune. On Friday, September 23rd, we can celebrate the beginning of fall in the northern hemisphere, or opposite, the beginning of spring in the southern hemisphere. This is the September or autumnal equinox, when the sun's path in the sky, called the ecliptic, crosses the celestial equator, as we see here in the stellarium. So that means around this time you have about an equal amount of day and night. And then we're going to transition into a time, at least in the northern hemisphere, where we have a shorter day and longer night until the winter solstice in December at the shortest day of the year. But at this point, we have equal day and night. Equinox means equal night. And as I usually say, just a reminder of the change of seasons as we move through the year. Then on Monday, September 26th, we're going to head back to where Jupiter is again. And by this date, this is when Jupiter is also at opposition, when it's opposite of the sun in the sky and closest to Earth in the solar system, which then definitely means Jupiter is biggest and brightest in our sky. You can definitely see it with your naked eyes. You don't need a telescope. So it's going to look really brilliant as a non-twinkling star. But if you do have that telescope, take a look, because it gives you a better view of its cloudy bands that make up its atmosphere, and those moons, maybe the 4 Galilean moons, come into view even better, which is great. And even by this time, for opposition of Jupiter, Jupiter is still about 367 million miles away. That's about 33 light minutes away, but that's the closest right now Jupiter will get, and it will allow it to look like this beautiful gem in the sky that's non-twinkling. Just a reminder of the largest planet in our solar system. And the last thing we'll do in this episode is look at the highlights for just the stars and constellations for the month of September around the 9 o'clock hour in the evening. So we're going to actually start in the western side of the sky, where we actually find some early summer and even considered spring objects finally setting in this part of the sky here. We have the really bright star of Arcturus right there, part of Boötes the herdsman, that's gotten pretty low, and sometimes we like to say that the arcing handle of the Big Dipper arcs to Arcturus. And also, speaking of the Big Dipper has been getting lower in the northwestern part of the sky, especially if you're in more southern latitudes. It's getting a little harder to see in the evening, but it's still kind of lingering or hanging on in the sky. If we go to more summertime objects, you'll still have some time to see them even in September, even when fall begins. They don't just disappear right away, so we still have a decent view in the south and southwest of Scorpius, the scorpion, with the bright star Antares, and the teapot shape here, the asterism inside the constellation of Sagittarius, the centaur, all inside of the galactic center, that really bright region of our Milky Way, where we know a black hole exists right about there. At this time of the year, we have a really great view of the summer triangle. So in September, it's pretty much straight up in the sky, the three bright stars that make up this beautiful asterism here. You have the brightest of the three, that's Vega in Lyra the Harp. The second brightest here, that star Altair, is part of Aquila the Eagle, and this star, one of my favorites, Deneb, the really giant blue star, forming the tail of Cygnus the Swan. But if you're wanting to look out for some more fall stars and constellations now rising this time, you got to look over to the eastern side of the sky, kind of where you find Saturn and Jupiter. This is Saturn right here, and that's Jupiter down there. You have to wait a little later to see it. But in this area, we have some great constellations like Pegasus, the winged horse here, maybe Andromeda, the princess. Her mother, who was not so nice to Andromeda, Cassiopeia, the W shape. That's great. Cassiopeia is a great way of also finding that North Star, part of the Little Dipper, right there. When the Big Dipper goes away, part of the Big Bear, which is usually the best way to find the North Star, the end of the bowl of the Big Dipper, that's getting pretty low. So a good alternative at this time of year is finding Cassiopeia. The open side of the W shows you that North Star in the sky. Of course, there are many more constellations that we can look at. If we turn on all of them at this time of the year, of course, there are so many more, but it's fun to kind of see some of those sets for the last season and the new ones rise for this upcoming season off to the east. Hey, that's it for another edition of our Sky Tonight program. Thank you for tuning in. And if you drop by, please make your way to the Museum of Arts and Sciences and definitely the Lowman Planetarium. We're running shows every day. If you want any more information about our programs and our shows, check our website online and tune into our various social media channels. We're posting great content all throughout the year from many different parts of the museum. So hope to see you back here again. I'll say go Artemis and SLS, and of course, happy stargazing.